Indeed, Elizabeth. I've learned also so much and very grateful to the fantastic panel. Rafael, dear friend of Webit, Professor Stefano Bini, and Professor Maki Sugimoto. Such a pleasure to have you with us. Thank you so much, all of you. Coming up next is a keynote with so much of knowledge. And I have to warn you, you have to have some deeper understanding of how computing works, because we are going to be talking about leveraging computer models and simulations to make you live longer and healthier. And I have the pleasure to have Prith Banerjee, Chief Technology Officer at ANSYS with us. The floor is yours.
Good morning. My name is Prith Banerjee, and I am CTO at ANSYS. I'm going to talk to you today about leveraging computer models and simulation in the healthcare industry to make you live longer, healthier lives. So let's begin. In the healthcare industry, people have not used simulation thus far. If you look at the total R&D spend across all healthcare segments in the healthcare industry, it's about $240 billion, of which about $180 billion is spent by biopharma companies alone in terms of drug discovery, drug development, drug manufacturing, and drug delivery. Moving on to medical device companies that make, say, pacemakers or hospital equipment companies like MRI scanners and CT scanners, there is about $32 billion of R&D spend. And in that, these companies are investing in product design, in silico trials, product manufacturing. And then there's the area of clinical applications where companies are building out applications to help doctors and nurses in guiding them for various clinical applications, as well as building out digital twins in different industries, such as assets, healthcare assets, and personal digital avatars. Before I go into the use of simulation in the healthcare industry, I just wanted to provide a very quick overview of ANSYS simulations. So at the core, we are a leading simulation and modeling company. And at the basic level, we model different physics. So we model structural physics using finite element analysis, or fluids physics using finite volume methods, or electromagnetics physics using finite domain difference time domain methods, and so on. On top of it, we have system software simulation capabilities such as digital twins, embedded software safety analysis. On top of it, we build out entire simulation platforms such as Granta Materials Platform or the Minerva Process Data Platform. And then we use all of these solutions to drive, to work with our customers in aerospace and defense companies, automotive companies, energy companies, and this presentation will be focused on how we are able to use simulation in the healthcare industry. So at ANSYS, we are working towards bringing sort of the future of technology in the healthcare area along these 7 pillars that I'm showing on the slide. At the bottom is showing how we work with various academic partners, various universities, clinical partners in hospitals, regulatory agencies like the FDA to help them in their digital transformation journey, which is the second pillar, using digital technologies in the healthcare industry. Now, to do this, we essentially are working on various sort of 3D models, simulation models of different virtual organs inside the human body, such as the heart, the lung, the eyes, and the brains. And then using those virtual organs to help sort of our customers who are building out either new drugs or new medical devices to help them in their in silico clinical trials. Also working with various companies in building out clinical and non-clinical apps and building out entire digital twins, such as the personal digital avatar. So let me kind of show you a few of these examples in a little more detail. The first case is that of how do we digitize healthcare, right? So when you are talking about a particular patient and the patient has a problem with a heart, right? The patient will go to a hospital, will do an MRI scan. That MRI scan is converted using tools such as Synopsys Simpleware or Materialize into an STL file, which is what can be viewed, read, and used by an ANSYS LS Dyna. And then we take and we look at the interaction of a medical device like a pacemaker with the human heart, and we may look at different sizings of the pacemaker, right? And we can use different optimization tools like OptiSlang, or trying to look at printing this. How do you manufacture this particular device, right? Using 3D printing that we can do through ANSYS additive solutions. And essentially, this is the type of fully electronic workflow, the digitized workflow in the healthcare industry. So an example of this is shown here. If you are trying to invent a new device, right, like a catheter, electromagnetic tool, or whatever, right, and so you for analyzing doing the virtual prototyping of this tool, right, you may have to use a tool such as antenna design optimization. That's the tool that is shown on the left-hand side, right? We using our ANSYS tool called HFSS, or for doing electromechanical part design, right, where the electronics is interacting with the mechanical parts, and you can use ANSYS mechanical or MAPDL, or to do a testing that if you drop this material right on the ground, whether it will break or not, you can do through LS-DYNA drop testing. So you can use a bunch of those simulation tools to test out a part completely virtually on the computer before you do any physical prototyping. That is the value of simulation. So what we have done is we have now built out clinically validated patient-specific models of different virtual organs, such as the human heart. The human heart is the most complicated device that we have, right? That nature has created, because 70 times a minute, the human heart receives electric signals. In response to the signals, certain valves open up and close, muscles contract, and the blood flows from the atrium to the ventricle. That is a fluid flow. The muscle flow, a contraction is modeled through mechanical. So it's the electrophysiology, mechanical, and fluid flow that we need to simulate. Now, these simulations, to be accurate, you will have to do a lot of detailed simulation. And this is exactly what we do with our LS-DYNA for the virtual heart model. So you can take this. So what I'm showing in this slide is actually clinically validated patient-specific models, which is showing that here is the simulation that is happening of a left ventricle. There's blood flow going from the atrium to the ventricle, and the results of the simulation through simulation matches exactly the results through measurements, right? And so this is what we mean by clinically validated patient-specific models. Now we can take these virtual models of the heart and then use it to drive sort of new trials of, say, medical devices like a pacemaker. So suppose you are a healthcare company, right? And you like say Medtronic, and you're building out a new pacemaker. In the past, they had to test the pacemaker and do clinical trials. I test it on first some mice, some donkeys, monkeys, and then try it on 1 human, 2 human, 10 humans, and ultimately you test it on 5,000 humans and you say, okay, this is ready for operation. So instead, the in silico trial, the trial that you do through a computer, is shown here. You create virtual patient models of, say, 5,000 patients. Some are male patients, some are female patients, some obese patients, some thin patients, and you use different materials to look at patient-specific geometry library of these patients, and then look at different biometric material properties of the pacemaker and so on, and you put it all together in a large, gigantic sort of computational simulation, and you run it on different use cases on sort of millions of processors on a cloud. And this is how you essentially on the computer do clinical trial of this new medical device, right? And essentially you can get certification from the FDA. This is the future that we are trying to enable through simulation. Now, much of the work that we do in this healthcare simulation area is done by ANSYS itself, but it's not just ANSYS. We do a lot of partnerships with companies such as Optimize, who we partner with. It's a startup that enables patients to do eye surgery. So essentially, they are using ANSYS software in their backend running on the cloud, but they are creating this front-end app that run on a phone and help an eye surgeon in making eye surgery. Or we are partnered with CATFM Medical in terms of obstetric sleep apnea testing, or working with Terranova in terms of stent sizing and navigation. So essentially, we are partnering with a bunch of clinical app companies that are using ANSYS software in the backend, running on the cloud to help with different workflows in healthcare settings, right? And other examples are CATFM Medical, Twin Sites, Cases, ADAS 3D, and so on. So I went through a whirlwind sort of introduction of the area of computer modeling and simulation, how we will enable you to build, lead healthier lives. Thank you very much for your attention.